Hey guys, today I thought I'd make a short video and I really want to do two things. I want to review a little bit about motion, and then I want to be able to introduce you to the final piece of information that you're going to need to complete the worksheet that I gave you a few weeks ago that we didn't get around to doing. It's the worksheet, I'll show it to you. It says at the top, the physics classroom. I don't know if you remember, I printed it off in the hopes that we would be able to do it, but it actually required some information that I had not taught you yet. So I'm hoping to be able to do that today, and then this week you can do these problems. I think you will enjoy them. So the way that I'm hoping to do this, let me set this over here. The way that I'm hoping to do this briefly is to just answer three questions. What variables do we use to describe motion? How are these variables related to one another? And how can we use these relationships to predict motion? So we'll start our review here. What variables do we use to describe motion? Of course, we use many variables to describe motion, but the ones that you need to be the most familiar with are the ones that I have written on the board here. Velocity, distance, time, acceleration, initial velocity, and final velocity. Keep in mind that we're only dealing with motion in one dimension, and what that means is that motion in a straight line. And also, we're only dealing with average velocity and average acceleration over a given period of time, rather than the actual velocity or acceleration at any given moment in time. Okay, so we're dealing with average velocity, average acceleration. Understanding these variables and how they are related allows us to solve some pretty cool motion-oriented problems, and this is basically the foundation that you're going to need for all other further exploration of motion in physics. So this is the basics of motion. How are these variables related to one another? Well, we can describe the relationship of these variables in four classic kinematic equations. Four classic kinematic equations are usually taught in a first-year physics class, and I've actually already taught you the first equation, which is the equation for acceleration. Acceleration is equal to final velocity minus initial velocity divided by time, and you've done a few worksheets using that equation, and you've done a very good job with it. So I think you're ready for the next three equations, which really aren't that difficult. The math isn't any more difficult than what you've already done. The equations are just different. And by learning these equations, you get a better understanding of how these variables are related to one another, which is the point. So I'm just going to briefly show you the three that you have not been introduced to yet. So the second one, the first one is acceleration. The second equation is actually related to velocity, and it's really just simply another way of expressing average velocity, okay? So you know that velocity is distance divided by time. Well, you can also express that like this. Distance divided by time is equal to initial velocity plus final velocity divided by 2. That at first seems a little bit complicated, but if you remember, we're dealing with average velocity. And if I wanted to get the average of, let's say, 5, 7, and 9, if I wanted to get the average of those numbers, I would simply add 5 plus 7 plus 9, and then I would divide them by 3. So if you want to get the average velocity, what you can do is you can take the initial velocity, that's the first number, plus the final velocity, a second number, and divide that by 2, and that would get you the average velocity. And that average velocity is also equal to distance divided by time. So this equation can be helpful if you're trying to solve for a particular variable like initial velocity, and you have distance over time, you would be able to solve for that. Okay, this third equation you'll probably use a lot. I think I did the solutions for the worksheet that you're going to be doing, and I used this equation quite a bit. This is the equation for distance, and it's pretty straightforward. Basically, distance is equal to initial velocity multiplied by time, okay? And then you add that to 0.5 multiplied by acceleration multiplied by time squared. So let me say that again. Distance is equal to initial velocity multiplied by time plus 0.5 multiplied by acceleration multiplied by time squared. This equation is especially useful when initial velocity is 0, which it often is. If initial velocity is 0, then this whole side of the, or a whole part of the equation goes away, because anything times 0 is 0. So you would just, it'd be 0 plus this. So this was pretty easy to use, and you'll use it a lot. And then the final one, which can occasionally be useful, is down here. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times distance, okay? So the math is pretty straightforward, and all you got to do is just plug in the numbers. The equations with these symbols, they look complicated, but it's really pretty simple math. You just got to plug in the numbers and do the math. So that's kind of how the variables are related to one another. The final question that I wanted to quickly go over was, how can we use these relationships to predict motion? You can use these equations to solve problems by following 3 steps. And we've talked about these 3 steps, and I just want to go over them again quickly. Number 1, you want to identify the variables that are given to you. Okay, so in the problem, you read the problem, the first thing that you want to do is circle the variables, you know, these things down here. Circle the things that are given to you. The one that you want to watch out for is initial velocity. Oftentimes, initial velocity, they won't mention of, you know, they're not going to say initial velocity, but you'll be able to figure out that they're starting from rest. Okay, so that would be the initial velocity. The other thing that might come up occasionally is if they give you a constant. So if they say, for example, that you know, Sally free falls for 5 seconds, you would have to kind of figure out, you know, she's on Earth, so, and she's free falling, so they're talking about gravity, and that's a constant, and gravity is acceleration. So that might come up a couple of times as well. Keep that in mind. So step number 1, identify the variables that are given. Step number 2, look at the variables that you have, okay? And then what you're going to want to do is figure out which equation can I use to solve for the variable that they're asking for, okay? So number 2 is to select the appropriate equation. And then step number 3 is simply to plug in the numbers and do the math. Now, some problems may be multi-step and may require you to be a little bit creative. In other words, you may have to use 2 variables to solve for a third variable, okay? And then use those 3 variables to solve for the variable that they're asking you for. And I have an example problem here on the board that we're going to go through that actually requires you to do that. Okay, I think this is number 4 in the worksheet that you're going to do. Let me get my solution here so I don't have to redo the math. All right, I have the problem on the board behind me, and the first thing that you're going to want to do is, of course, read the question. We have a race car accelerates from 18.5 meters a second to 46.1 meters a second in 2.47 seconds. Determine the acceleration of the car and the distance traveled. Okay, so what am I going to do first? I'm going to identify the variables that they have given to me. So a race car accelerates from 18.5 meters a second to 46.1 meters a second in 2.47 seconds. Determine the acceleration and the distance. So 18.5 meters a second is going to be initial velocity. 46.1 is final velocity. And then I have the time here, 2.47 seconds. Okay? And then I need to figure out acceleration and distance. Okay, I'm going to note that all of the units of measure are already in the MKS system. So we have meters per second, we have seconds. So that's convenient. And by the way, the worksheet that you're going to do, you're not going to have to do any unit conversions. They're all going to be meters per second. So that'll be easy. Then I'm also going to note the number of significant digits that my answer is going to be in. So I got 3 here, I got 3 here, 2.473. So I know that I'm going to need to give my answer with 3 significant digits. So I'll make a note of that. Okay, so let's figure out what equation am I going to need for acceleration and then for distance. Well, I know that for distance, I'm going to be using this third equation for distance, and I'm looking at it and I see that I need acceleration, I need time, and initial velocity. And the problem gives me the initial velocity, it gives me the time, it also gives me the final velocity, but it doesn't give me the acceleration. So I'm going to have to do something first before I can use this equation. And of course that's going to be to solve for acceleration. So I look at acceleration, I see that I need time, initial velocity, and final velocity. And do they give that to me? Yes, they do. So the way that I'm going to approach this problem is going to be to first solve for acceleration. And then once I have that, I'm going to be able to use all that information to solve for distance. So let's go ahead and do that. I'm going to need to solve for, I'll use a different color marker because it's more fun that way. Let's use green. Okay, so I got acceleration is equal to, so I got the final velocity, which is going to be 46.1 meters per second, minus the initial velocity, which is 18.5 meters a second. And I need to divide that by time. And we have 2.47 seconds. Okay? So we will do the math. I actually grabbed the wrong sheet. Here it is. We'll do the math, and we get 11.17 meters per second squared. And I'm going to pause right here and say that maybe what you should try to do is pause the video and solve the problem on your own, and then push play and see how I solve it now. So go ahead and do that if you haven't already, if you didn't think of that before me. All right, we got acceleration equaling 11.17 meters per second squared. Now we have everything that we need to be able to use this equation right here. So let's go ahead and for space purposes, I'm just going to write, I'm going to erase that and put acceleration over here equaling 11.1 second meters per second squared. Okay, I'll get some room for us. Now we're going to use all that information and we're going to plug it into this third equation right here. So we got distance is equal to 18.5 meters per second multiplied, I'll put the parentheses here to make it a little clear, multiplied by 2.47 seconds. Okay, so we got initial velocity multiplied by time, and then we're going to add that to 0.5, and we're going to multiply that by our acceleration, which is right here, 11.17. Let me get this out of the way here, maybe, we'll see. Uh-oh. And then we are going to multiply that by our time, and what time is 2.47 seconds. And that's going to be squared. Okay? And then we'll simplify this. I'll go ahead and multiply these two numbers for you. We get 45.69. Okay. And then, so 18.5 times 2.47 is 45.69. And we're going to add that over here. I'm going to simplify this a little bit too. We'll go ahead and multiply these two things together here. And we get 5.58. Okay. So 0.5 multiplied by 11.17 is 5.58, and I'm going to multiply that by my time squared, and 2.47 seconds squared is going to be 6.10. Okay. And then we'll go ahead and multiply these together, and we get 34.03, and we're going to add that to our 45.69, and that's going to equal 79.72 meters. And significant digits, I needed 3. I got 0.72, so I can round that down. .7 meters. Okay. Close that. So distance is equal to 79.7 meters. So to determine the acceleration of a car and the distance traveled, we have acceleration equaling 11 point, and again, significant digits, will round this up to 2. Acceleration is equal to 11.2 meters per second squared, and distance is going to be equal to 79.7 meters. So the worksheet that I have, I said that I will put it on Google Classroom when I post this video, just in case you don't have it. But There's 20 problems, and throughout this week, what I'd like you to do is to go ahead and do those problems to the best of your ability. Remember that the answer key is in the back, so you'll be able to double check, and you'll just be using these equations in the same kind of format that I just showed you how to do. Now, you don't need to worry about reading or starting to read the next chapter yet. I'd rather have you focus on these problems and on these variables. And then when we meet next week, you can go ahead and turn your test in to me, and we'll talk a little bit more about motion. We'll go over these problems. I also want to go over some of those difficult problems that were the Newton's second law of motion problems that we didn't get to go through last time we met. So we'll go through those, we'll go through these, and then we'll start to talk about energy, which is what the next chapter is about. So if you have any problems with this, please, you can ask me a question on Google Classroom or in the comments for the video. And I look forward to seeing you next week. We'll see you later, guys.